Good morning, learners and viewers. Welcome to the session for Quantitative Analysis for Managerial Applications, MMPC 5. We were discussing in the last session about Block 1. We have already completed more than 2 units. We were in measure of central tendency. Continuing with that, we have a knowledge of mean, median, and mode. Today, we will be talking about an empirical relation between these three, which is mean minus mode is equal to 3 times the difference between mean minus median. Or, easy to remember, it is mode is equal to 3 median minus 2 mean. Now we will see how these relations and formulas are used practically. Suppose we have, during the conduct of a research study involving a group of 40 library staff, the following scores in a library attitude test were obtained. Find the mean, median, and mode of the marks obtained. This is the basic problem which is given to us. We will reframe it in this form. That means column number 1, that is class intervals, and frequency is given to us. Since we have to find mean, median, mode. For finding, first of all, for finding mean, we have to find the summation of fx. That means we will be multiplying. We will first initially we will be finding the mid values. As you are aware of, mid value is obtained by adding lower limit and upper limit and dividing them by 2. In this case, this is 0 plus 10 divided by 2. That comes out to be 5. Here, the difference between the upper limit and the lower limit is 10. So we will be adding 10 to all values. Then 5, 15, 25, 35, and 45. Second step is multiplying f by x. So we will get fx. That is 45 into 5, 20 into 15, 14 into 25, 7 into 35, 3 into 45. In the last, we will be adding them. That comes out to be 1255. In the middle, we can see that a cumulative frequency column is there. Now the question arises, why we have calculated cumulative frequency? As you are aware that for finding median, we have to use cumulative frequency. Now the question arises, how this cumulative frequency is obtained. In first step, in front of 45, we will write 45 under the column of cumulative frequency. Second part will be 45 plus 20, that is 65. Again, 65 plus 14, that is 79. 79 plus 7, that is 86. And 86 plus 3 is 89. The last value in the cumulative frequency will be same as the sum of the frequency. That is, here we have 89 in the last element in the cumulative frequency column, and the summation of frequency is 89. Now we will be moving to first, that is mean. Mean, we know that x bar is equal to summation of fx divided by n. Here summation of fx is 1225 and the summation of n, that is frequency, is 89. By dividing, we get 14.10. Second step is to calculate median. We have a formula for median. ME is equal to L plus N by 2 minus PCF upon F into I. Going back to the problem, this is what we have calculated. First of all, for finding median, we have to find N by 2. N by 2 is 89 by 2, which comes out to be 44.5. For that, we have to find the median class. In the cumulative frequency column, we have to find a number nearer to 45, 44.5. Here in this case, this is 45. Going back to the formula, your L that has already been marked as red. That is 0, the lower limit, 89 by 2 minus PCF. PCF here is 0 because there is no element above 45. And the frequency of the median class is 45. And the difference between the upper limit and lower limit is 10. After calculating this, we will get 9.89. Now here the thing is that, as we know, there is an empirical relation between mean, mode, and median. So straight away, without doing more of the calculation, we can evaluate mode. Mode is equal to 3 median minus 2 mean. After putting up the value, we will get mode equal to 1.47. Now, how to locate mode graphically? In a group data, the value of mode can also be determined graphically. In graphical method, the first step is to construct the histogram of the given data. The next step is to draw two straight lines diagonally on the inside of the model class. That is, model class is the class which has maximum frequency. Starting from the upper corner of the bar to the upper corner of the adjacent bar. So here we can see that a cross has been already marked. Now, where these two lines incline, meet, we have to draw a perpendicular line on the bottom. That means on the x-axis. The value which will come where this perpendicular line meets x-axis will be the mode. That means here we can see that it's almost 35. The chief advantage of mode is that it is by definition the most representative value of that distribution. For example, when we talk of model size of shoe or garment, we have this average in mean. Like median, the value of mode is not affected by the extreme values, and its value can be determined in open-end distribution. The main disadvantage of mode is its intermediate value. That is, we cannot calculate its value precisely in a group data, but merely estimate it. When a given set of data have two or more than two values x maximum frequency, it is a case of bimodal or multimodal distribution, and the value of mode is not unique. The mode has no useful mathematical properties. Hence, in actual practice, the mode is more important as a conceptual idea than as a working average. See, there exists an empirical relation between mean, median, and mode has been obtained. A distribution in which mean, mode coincide is known as symmetrical bell-shaped distribution. This bell-shaped word will be used in normal distribution. If a distribution is skewed, that it is not symmetrical, then mean, mode, and median will not be equal. In a moderately skewed distribution, a very interesting relationship exists among mean, median, and mode. In such a type of distributions, it can be proved that the distance between mean and median is approximately 1/3 of the distance between the mean and mode. This is two types of distributions. Here we can see that one diagram has elongation on the left side, and the other one has elongation on the edge. And in the center, we have mode. And simultaneously, nearer to them, nearer to mode is median and then mean. Similarly, on the right side, we can see mode, median, and mean. So, as far as that statement is concerned, the relationship can be expressed as mean minus median is equal to one third of the difference mean and mode. And recombining, we will get mode is equal to 3 median minus 2 mean. Now comes geometric mean. The geometric mean is an average that is useful for sets of number that are interpreted by their product and not their sum. That is rates of growth. So that we have a relation. Geometric mean is nth root of x1 plus x2 plus x3 till xn. You can see that with this simple example, we have 6 values: 34, 27, 45, 55, 22, 34, and we have to find geometric mean. So mathematically, we have to multiply it raised to the power 1 by 6, that is 6th power. Was that after calculation, it comes out to be 34.545. When the number of observation is 3 or more, the task of computation becomes quite tedious. So multiplication and then finding the nth root. So in that case, to make calculations simpler, we take the help of logarithm. A transformation into logarithm is useful to simplify calculation. If we take logarithm on both sides, then the formula becomes log gm is equal to 1 by n into log x1 plus log x2 plus log x till log x. We have a value and we have to no doubt find geometric mean. So in that case, we have to take anti-log of what we have obtained on the right side. So that becomes anti-log of summation log x by n. For group data, the geometric mean is calculated with the following formula. That means with log x, we will be multiplying frequency. Rest, everything will remain the same. Geometric mean is specifically useful in the construction of index number. It is an average most suitable when large weights have to be given to small values of observation and small weights to do large value of observation. This average is also useful in measuring the growth of population. Then comes harmonic mean. Harmonic mean is the average which is useful for set of numbers which are defined in relation to some unit. For example, speed, that is distance per unit of time. In that case, how that is evaluated? X bar is equal to n upon summation of 1 upon x1. Suppose we have these numbers 34, 27, 45, 55, 25, and 34. So we have to calculate the harmonic mean. So in that case, what we do, there are 6 observations, 6 divided by reciprocal of 34, summation reciprocal of 34, 27, 45, 55, 22, and 34. After evaluating it, we will get 33.017. The harmonic mean is useful for computing the average rate of increase of profits or average speed at which a journey has been performed, or the average price at which an article has been sold. Otherwise, its field of application is really restricted. Then comes quantiles. Quantiles are the related positional measures of central tendency. These are useful and frequently employed measures of non-central location. The most familiar quantiles are quartiles, deciles, and percentiles. So we will start with quartile. Remember it, there are 4 quarters. That means quartile are those values which divide the total data into 4 equal parts. Since 3 points divide the distribution into 4 equal parts, Now we will be having three quartiles and we name them as Q1, Q2, Q3. Now the thing is what actually these Q1, Q2 and Q3 mean. The first quartile Q1 is the value such that 25% of the observation are smaller and 75% of the observations are larger. Second one is Q2, that is also known as median, which means 50% of the observations are smaller and 50% of the observations are larger. The third one is quartile 3, that gives the value of 75% of the observation are smaller and 25% of the observations are larger. So we have a basic relation. Since this is similar to what we have learned in finding median. Now here representation has been changed, but the concept remains the same. We have to be very much conscious about what has been asked and how we have to apply. Here, Qj is equal to L plus Jn by 4 minus PCF upon F into I. Now here you see, in median, we did n by 2. Here, it is Jn by 4 because we are talking about quartile, where L is the lower limit of the quartile class, PCF is the preceding cumulative frequency of the quartile class, F is the frequency of the quartile class, and I is the size of the quartile class. Here, only three values will be there. J, if we have to find Q1, so we will be replacing J by 1. So in that case, the formula will remain as L plus N by 4 minus PCF upon F into I. And for Q2, that J will be replaced by 2. So it will become N by 2, which is similar to the formula of median. That is L plus N by 2 minus PCF upon F into I. And for quartile 3, this will become L plus Q3 is equal to L plus 3N by 4 minus PCF upon F into I. Then comes decile. Decile means dividing into 10 equal parts. And when we are dividing the data, whole data into 10 equal parts, that means we have 9 points. The decile is denoted by D1, D2 till D9. But what is the change in the formula? dk is equal to L plus Kn by 10 minus PCF upon F into I, where K will take the value of 1 to 9. Then comes percentile. Percentile means 100 part. That means the whole data is divided into 100 equal parts. That means we have 99 points. 99 points will divide the whole data into 100 equal parts. That is represented by P1, P2 till P99. So PL is equal to L plus Ln by 100 minus PCF for F, where L will take the value of 1, 2, 3 till 99. The median by locating and by 2th observation on the y-axis. Now we will draw a horizontal line from that point in the cumulative frequency curve. And from where it meets the curve, draw a perpendicular line on the x-axis. The point where it meets the x-axis is the value of the median. Now we will see over. This graph has been plotted. Here we can see that it starts from bottom and it's moved towards. Different parts have been marked. Cumulative frequency of 100 has been done. And on the right side, we have divided into 100 equal parts. Now we have to find Q2. Q2 is basically median. How to determine? We know 50%, as the theory says, 50% will be on the higher side and 50% will be on the lower side. We have found 50% on the right corner. We have drawn a horizontal line where it is meeting the less than curve. At that point, we are drawing a perpendicular line that comes out to be Q2 is equal to 56.6. Now Q1 means 25% less than and 75% above. So right side, we will take 25.25, we'll draw a horizontal line on the curve. It meets, and from that point, we will draw a perpendicular line of x-axis. That point where it meets, the Q1 comes out to be 47.2. Now we have to calculate decile 2. Here, we will be taking 60%, and from that we will mark on the curve, we will draw an horizontal perpendicular line, and its value comes out to be D6 is 60, P 90% at the top. We will draw a line parallel to x-axis where it meets the curve. From that point, we will draw a perpendicular, which comes out to be 85. So we can see that just by simply drawing this graph, we can find out the values of this graph without using any mathematical relation. Now we move to unit 4, that is measure of variation and skewness. What is the significance of measuring variation? Measuring variation is significant for some of the following purposes. Measuring variability determines the reliability of an average by pointing out as to how far an average is representative of the entire data. Secondly, another purpose of measuring variability is to determine the nature and cause variation in order to control the variation itself. The third one is measure of variation enables comparison of two or more distributions with regard to their variability. What are the properties of good measure of variation? A good measure of variation should possess, as far as possible, the same properties as those of a good measure of central tendency. Following are some of the well-known measures of variation which provide a numerical index of the variability of the given data. And these four are range, average or mean deviation. Third one is quartile deviation or semi-interquartile range. And the fourth one is standard deviation. Absolute and relative measure of variation. Measure of variation may be either absolute or relative. Measures of absolute variation are expressed in terms of the original data. In case the two sets of data are expressed in different unit of measurement, then the absolute measure of variations are not comparable. In such cases, measures of relative variation should be used. The other type of comparison for which the measures of relative variations are used involves the comparison between two sets of data having the same unit of measurement but with different means. We will start with range. Range is the difference between the highest value and the lowest value of the distribution. Suppose we have this data with us 2, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10. The lowest value is 2 and the highest value is 10. When we will be subtracting 10 minus 2, we will be getting range as 8. Range is the simplest measure of variability to compute. However, it does not use all of the data. As the sample size increases, the range can increase, but the range can never decrease. For example, we have taken now 4 numbers, 2, 3, 5, 10. Range will be 10. Now we have increased the data, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, the range is 8. The range does not give any information about the nature of distribution of the values. Now, what is the coefficient of range? That is the relation between highest minus lowest divided by the highest value and that summation with lowest value. Then comes your quartile deviation. Quartile deviation is also known as semi-interquartile range. It is computed by taking the average of difference between the third quartile and the first quartile. So mathematically, it will be quartile deviation is equal to Q3 minus Q1 upon 2. Q3 is the third quartile, Q1 is the first quartile. And if we talk about in terms of relative measure corresponding to quartile deviation, then it is known as coefficient of quartile deviation. That is Q3 minus Q1 divided by Q3 plus Q1. The quartile deviation is superior to the range as it is not based on two extreme values, but rather on middle 50% of the observations. Another advantage of quartile deviation is that it is the only measure of variability which can be used for open-end distribution. The disadvantage of quartile deviation is that it ignores the first and the last 25% of the observations. Then comes your average deviation. The measure of average or mean deviation is an improvement over the previous two measures, and in this it considers all observations in the given set of data. This measure is computed as the mean of deviations from the mean or the median. All the deviations are treated as positive regardless of the sign. That is why we have using mod. That is average. Deviation is equal to, if we're talking in terms of mean, it will be the deviation from mean. That is summation of mod value x minus mean upon n. And if we are talking about in terms of median, that means in that case, average deviation will be summation of the difference between x and the median divided by n. There is an advantage in taking the deviations from median because the sum of the absolute deviations, ignoring the plus and minus sign, from median is minimum in actual practice. However, arithmetic mean is more popularly used in computation of the average deviation. The relative measure corresponding to the average deviation is called as coefficient of average deviation. So it is, if it has the average deviation has been computed from median, the coefficient of average deviation shall be obtained by dividing average deviation by the median. And if it is in terms of mean, so in that case it will be divided by mean. Although the average deviation is a good measure of variability, it is used, its uses are limited. If one desires only to measure and compare variability among several sets of data, the average deviation may be used. The major disadvantage of average deviation is it lacks of mathematical properties. It is more true because non-use of signs in its calculations makes it algebraically inconsistent. Now, the most important part, that is standard deviation and variance. Standard deviation and variance measures variability about the mean. Standard deviation is used in other statistics and is the most stable of the variability indices. If one reports the mean as the measure of standard tendency, then the standard deviation is also reported. The standard deviation is good for interval or ratio data. However, standard deviation is affected by the extreme values. Approximately 68% of the measurement, that is data, will fall within one deviation of the mean. 95% falls within two standard deviations, that is 1.96, and 97.7 is almost 100%, with falls in three standard deviations. The concept of standard deviation was introduced by Carl Pearson way back in 1893. In terms of symbol, standard deviation is denoted by sigma. And if we have an individual observations, then how it is evaluated. That means sigma is equal to under root of summation, the difference between x minus mean upon n. And if the data is grouped, that means frequency will come. So there is a minor chain, all values will be multiplied with x, and then their summation will be taken. Or it can be written as depending upon the data, nature of the data. The formula is going to change. The concept will remain the same. Here, in this case, we take summation of fx square by n minus summation fx by n whole square. There is a difference between the two. If we are taking mean from the deviation, that is d is equal to x minus a upon I, what we have been calculated when we were doing evaluating mean. Here, sigma is equal to summation ft square by n minus summation ft by n whole square. There is a difference between these two. Variance being the square of standard deviation, and it is denoted by sigma square. That means variance is equal to sigma square. Now, we will find out mean and standard deviation for this particular problem. Here, what is given to us? The table below provides the data for library membership of children in different age groups. That means we have different age groups and number of children are known. That is the frequency. Now, we will be taking this data. Membership fee is x denoted by x, and number of children is frequency, that is f. We have to calculate fx first. That means column number 4 will be evaluated first, that is fx. 30 into 10, that is 300. 40 into 8, 320. Similarly, we will be going till the last, that is 70 into 2, 140. We will be adding. That means first of all we need summation of f, that is n. That comes out to be 30. Summation of fx comes out to be 1290. And the last column we have to square x, and then it has to be multiplied by frequency. That means 30 square is 900. 900 into 10 is 9000. And similarly, we will be evaluating for all of the elements. And in the last, we will be adding. Now, first of all, we have to find the mean. Mean is summation fx by n, which is 1290 divided by 30, which comes out to be 43. That is, first part has been evaluated. Now we move to standard deviation. Standard deviation is given by sigma is equal to under root summation fx square upon n minus summation fx by n whole square. Now see the difference. In the first value, we have to find summation fx square, which is 59,900. It has to be divided by 30 minus a bracket. Now we need summation fx, that is 1290 divided by 30, and then its square. See the difference between the two. After evaluating, we get 12.15. Now comes coefficient of variation. For distribution having the same mean, the distribution with the largest standard deviation has the greatest variation. But when considering distribution with different means, decision maker can't compare the uncertainty in distribution only by comparing the standard deviation. In this case, the coefficient of variation is used. The coefficient of variation for different distributions are compared, and the distribution with the largest coefficient of variation value has the greatest relative variation. But I'm talking about its application. CV is basically denoted, found out by SD by x bar into 100. Now, the most interesting part is skewness and kurtosis. Skewness refers to as asymmetry of the distribution. Symmetry means that for a given deviation from the central value, there are equal number of observations on the either side. If a distribution is skewed, it will have a longer tail either towards left or right. The skewness is departure from the symmetry. In a symmetrical distribution, mean, mode, and median, all three are equal. And if a distribution has long right tail, it is positively skewed. And if it has long left tail, then it is negatively skewed. Now we will see to it. If mode is less than median, is less than mean, it is positively skewed. If mode is greater than median and median is greater than mean, it is negatively skewed. And if all the three are same, it is symmetrical distribution. Now, coefficient of skewness. Carl Pearson suggested a measure of skewness based on, no doubt, these are the three values, mean, mode, and median. SK, coefficient of skewness, as proposed by Pearson, is the difference between mean minus and mode divided by standard deviation. And we have another relation for it, that is 3 times of mean minus median by standard deviation. If now how interpretation is done, if SK is greater than 0, that distribution is positively skewed. If SK is less than 0, the distribution is negatively skewed. And if SK is equal to 0, it is symmetrical. In that case, all the three values are same. That is mean, mode, median are same. There is another relation provided by Pole. That is in terms of quartile and median. In that case, we won't be using mean. The SB is equal to Q3 plus Q1 minus 2Q2 divided by Q3 minus Q1. You are aware of that Q2 is median. Now, this data is given to us and we will be finding Carl Pearson. With the help of Carl Pearson formula, we will be finding coefficient of skewness. Now, column number 1 and column number 3 were given to us. We have evaluated the mid value. Mid value is 10 plus 12 divided by 2. That comes out to be 11. We can see that there is a difference of 2. So simultaneously we will be adding 2 till the last. So it will be 11, 13, 15, 17, 19, 21, 23. Now we have to calculate mean. For mean, we have to use a formula for the deviation. That is, first of all, we have to find the central value in the mid value column. It comes out to be 17 and it has been marked as red. So when we are evaluating D, that is x minus 17 by 2. Straight away, in the fourth column, at the center in front of 20, we will write 0. And above 0, we will be writing minus 1, minus 2, minus 3. And below 0, we will be writing plus 1, plus 2, plus 3. Now we have to calculate FD. FD is number of frequency, number of companies, that is F. F into D, that is 7 into minus 3, it comes out to be minus 21. 15 into minus 2, minus 13. Similarly, we will be evaluating for all the elements. And we get summation FD is equal to minus 9. Summation of frequency, that is N, is 100. Now we have to calculate FD square. So we have to 4 into 15, 60. Similarly, we will be doing for all the elements. We will get summation FD square equal to 250. Now, moving to the formula. First of all, we have to find mean. Since we have assumed, so we will be using the assumed shortcut formula. That is x bar equal to a plus summation fd by n into I. Here a is 17, summation fd is minus 9, summation n is 100, and your I is 2. That is the difference between the upper limit and the lower limit. After evaluating it, we will get 16.82. Now we have to calculate mode. Mode is straight away calculated by the formula L plus D1 by D1 plus D2 into I. Lower limit is 19 plus 5 by 5 plus 15 into 2, which after evaluation, it comes out to be 18.5. We have mean, we have mode. Now comes your standard deviation. Standard deviation is summation of fd square by n minus summation fd by n whole square into I. Putting up the values, 251 by 100 minus 9 by 100 whole square into 2. This I is not included in the under root. So many learners used to make this mistake that they include this I into under root. It's not in under root. After simply evaluating, you can see that it comes out to be 2.51 minus 0.0081 under root into 2. After evaluation, it comes out to be 3.1634. Now, going back to, now we have mean, mode, and standard deviation. We have Carl-Pearson formula for it because we have to apply Carl-Pearson in this problem. Sk is equal to mean minus mode divided by Sd. After evaluation, putting up the values, we get Sk equal to negative 0.5310. Now, what interpretation is drawn? That is the most important thing. The value of coefficient of skewness indicates that the distribution is negatively skewed, and hence there is a greater concentration towards the higher profits. Now we will be taking a problem with Pauli's method. If this data is given to us, that means sales is given to us, Q1 number of companies, F is given to us, and CF. Now, if you remember in Bole's methods, we have to evaluate quartiles because that is the relation between quartile. That is Q3 plus Q1 minus 2Q2, that is the median, divided by Q3 minus Q1. Now, here we will see how actually the formula what we just some time back heard, now how it is applied. We have to find quartile 1. So we will be using, first of all, we will be finding the size of the observation of the n by 4. That is, your n is 80. 80 divided by 4 is 20. Now, going back, we have to also calculate, since we have to evaluate Q3, Q1 median, so we have to calculate cumulative frequency also. That is 8 in front of 8. 8 plus 12 is 20. 20 plus 20 is 40. 40 plus 25 is 65. 65 plus 15 is 80. The last value in the cumulative frequency column is 80, and the summation of the frequency is 80. That is the confirmation that we have calculated cumulative frequency correctly. Now, that is 80 by 4, that is 20th observation. Now, we have to find value nearer to 20 or below 20. In this case, we straight away found 20 in the cumulative frequency column. Now, how that formula is applied? You know that Q1 is equal to L plus N by 4 minus PCF upon F into I. L will be 50. N by 4 is 20. PCF, cumulative frequency of the preceding class. Our classes here is 50 to 61. The cumulative frequency above 20 is 8. And the frequency of the Q1 class is 12. And the difference between the upper limit and lower limit is 10. So how that values are placed in the formula. That is 50 plus 20 minus 8 upon 12 into 10. After evaluation, it comes out to be 60. That means your Q1 is 60. Now, for finding out the median, that is, we have to calculate the n by 2th observation, that is the 40th observation. I will take you back to the problem. Here in the cumulative frequency column, you can straight away see 40. That means now here, your median class will be 60 to 70. Your cumulative frequency will be, PCF will be 20, and the frequency of the median class will be 20. So I will be straight away putting that. See the change over there? Q2 is equal to n by 2. Earlier it was n by 4. Now it is n by 2. Minus PCF upon F into I. That means 60 plus 40 minus 20 by 20 into 10. It comes out to be 70. Similarly, we will be evaluating for Q3. That is 3n by 4th observation. That comes out to be 60. Where that 60 lies. Now, we were talking about 60th observation. Here, as per the theory says, at 60, value will lie in the cumulative frequency column where it is 60 or somewhat above 60. That comes out to be 65. So here, we will be taking 70 to 80 class. Its frequency will be 25 and the PCF will be 40. Q3 is equal to L plus 3n by 4 minus PCF upon F into I. That is 70 plus 60 minus 40 by 25 into 10. Comes out to be 78. Now we have SB will be equal to Q3 plus Q1 minus 2 of median upon Q3 minus Q1. We will get negative 0.11. Here, by Bolle's method, the value of coefficient of skewness indicates the distribution is slightly skewed to the left, and therefore there is a great concentration of sales at the higher values than the lower values of the distribution. By Carl Pearson formula, the value of coefficient of skewness indicates that the distribution is negatively skewed, and hence there is a greater concentration towards the higher profits. Now comes your quartile deviation or semi-interquartile range. We know that quartile deviation is Q3 minus Q1 by 2, where Q1 is first quartile and Q3 is the third quartile. The relative measure corresponding to quartile deviation is coefficient of quartile deviation, and coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1. The quartile deviation is superior to range and it is not based on the extreme values but rather on middle 50% observations. Another advantage of quartile deviation is that it is the only measure of variability and which can be used for open-ended distribution. The disadvantage of quartile deviation is that it ignores the first and the last 25% of the observations. We have seen average deviation. Now, we move to block 2, that is probability and probability distribution. We have 4 units in it. That is, first unit is basic concept of probability. Next unit is discrete probability distribution. Third one is continuous probability distribution. And fourth one is decision theory. So first of all, we will start with probability. What it is all about. Probability is concerned with random experiments, data, demands, and inference to be drawn, and statistical inferences are never certain. Statisticians would be prompted to use prefixes or suffixes as likely or at most likely. What is the basic concept of probability? Probability and its concept are very important to interpret the inferential statistics. The theory of probability is the study of random experiments. In a random experiment, set of all possible outcomes is always known, but it is not possible to predetermine the outcome. For example, the probability of a coin toss resulting in either head or tail is 1. And the probability of a coin toss resulting in head is zero point 0.5 because the toss is equally as likely to result in tails, and there is only two possible outcomes. When you are going to flip a coin, either tail or a head will come. Probability deals with calculating the likelihood of a given event's occurrence, which is expressed as a number between 0 and 1. An event with probability of 1 can be considered as certain event, and an event with a probability of 0 can be considered as an impossible event. Now, the thing is that sun is always going to come from east. That is a fact. And the probability is always 1. And the sun will come from west. That is an impossibility. That means its probability is 0. In other words, with the help of probability, we can assign a measure to the uncertainty with the occurrence of each possible outcome of a random experiment. Now the question arises, what is the probability of getting a red card from a pack of cards? Now we'll try to understand how this is evaluated. For that, we have to know some basic definitions, the concept. We'll start with experiment. Another question arises, what is meant by an experiment? The term experiment is used in probability theory in a much broader sense than in physics or chemistry. Any action, whether it is tossing of a coin or measurement of a product dimensions as to a certain quality or the launching of a new product in the market, constitute an experiment in the probability theory terminology. Second one is sample space. The set of all possible outcomes of an experiment is defined as the sample space. If we talk in terms of a flip of a coin, the sample space will be either a head or a tail. Then comes your event. An event in probability theory constitutes one or more possible outcomes of an experiment. Thus, an experiment can be defined as a subset of sample space. The experiment is toss of a coin, flip of a coin. Sample space is tail and heads. An event is getting a tail on the toss. Still, we are just in the phase of understanding the concept. We have not evaluated the probability as yet. Now comes the definition of the probability. It can be probability is defined in many ways, but normally we pick up two, that is classical definition of probability and an axiomatic definition of probability. Before defining probability, several other definitions are also needed to be understood. Then comes your random experiment, an experiment or trial whose outcome is not perfectly predictable, but for which the set of all possible outcomes is repeated. Trial is known. For example, toss of a coin, outcome will be either a head or a tail. Then comes your random variable. A random variable is an assignment of numbers to the possible outcome of a random experiment. For example, consider tossing 2 coins. The number of heads showing when the coin lands is a random variable. Let the number of tails be t. The random variable assigns the value of 0 to the outcome tt. The number 1 in the outcome th and the number 2 in the outcome as hh. Then comes outcome space and events. The outcome space is the set of all possible outcomes of a given random experiment. The outcome space is more often denoted by the capital letter S. An event is a subset of outcome space. An event is determined by a random variable. Outcomes are the set of all possible results in the random experiment. Then comes the nature of the event. First one is exhaustive event. Exhaustive events are a set of events in a sample space such that one of them compulsorily occurs while performing the experiment. In simple words, we can say that all the possible events in a sample space of an experiment constitutes exhaustive events. For example, while tossing an unbiased coin, there are two possible outcomes, head or a tail. So these two outcomes are exhaustive events, as one of them will definitely occur while flipping of the coin. It's very well understood. Coin is not going to stand straight. It will come land on the ground. Then comes your disjoint or mutually exclusive events. Two events are disjoint or mutually exclusive if the occurrence of one is incompatible with the occurrence of other. That is, if they can't both happen at once, if they have no outcome in common. Eventually, two events are disjoints in their intersection, is the empty space set. Then comes your independent events. Two events, A and B, are statistically independent. If the chance that they both happen simultaneously is the product of the chances that each occurs individually, or knowledge that one event has occurred does not give any information about whether the other event has occurred or not. That is, this can be understood by taking up an example. Getting head on the first row and getting head on the second row are two independent events. So they are not interrelated. Equally likely events. Two events are said to be equally likely if the occurrence of none of them is expected in the preference to others. Equally likely events are those events which have an equal probability of occurring. For example, when we are going to toss an unbiased coin, the probability of getting a head is 1 by 2, and probability of getting a tail is 1 by 2. So it is an equally likely event. When we roll a dice, the probability of getting 1 is 1 by 6, of getting 2 is again 1 by 6. Till 6, we have 1 by 6. That means this is an example of equally likely event. However, the probability of drawing one red ball in a bag of 3 blue and 2 red ball is 2 by 5. And the probability of drawing a blue ball from a bag of 3 blue and 2 red balls is 3 by 5. We can clearly see that these events are not equally likely to occur. Now comes the mathematical definition of probability. If n is the number of equally likely, mutually exclusive, and exhaustive outcomes of a random experiment, out of which m outcomes are favorable to the occurrence of an event A, then the probability that A occurs is given by PA. And mathematically it is PA equal to number of outcomes favorable to A upon total number of exhaustive outcomes. All these approaches, however, share the same basic axiom. These axioms are fundamental to probability theory and provide us a unified approach of probability. Or rather, we can say that probability is basically denoting probability. The probability can be, for an event, can be defined as favorable cases upon total number of cases. Now see what the axioms are. A probability of an event A is written as PA, must be a number between 0 and 1, and both values are inclusive. That means probability of any event will be between 0 and 1. The probability of occurrence of one of the other of all possible event is equal to 1. As S denotes the sample space or the set of all possible outcomes, it is written as PS equal to 1. In tossing a coin once, that means head or a tail is 1. If two events are such that occurrence of one implies that the other cannot occur, then the probability that either one or both will occur is equal to sum of their individual probabilities, probability of head and probability of tail. Summation of these will be equal to 1. Now, we move to some complex situations where probability has to be evaluated. Suppose in a survey, it was found that 21 people liked product A, 26 liked product B, and 29 liked product C. If 14 people liked product A and B, 12 people liked product C and A, and 14 people liked product B and C, and 8 liked all the three products. Now the question is, how many liked product C only? We know there are three products, A, B, and C. Now, in the problem, it is stated that 21 people like product A. So we will straight away write NA equal to 21. 26 like B, and B is equal to 26. And 29 like C, that is NC is equal to 29. Now, the second line states that if 14 people like product A and B, that means an intersection of A and B. It is denoted by N, A intersection B is equal to 14. 12 C and A, that means C intersection A is 12. 14 are those who liked B and C, that means B intersection C will be 14. And there are 8 which liked all the three. That means N, A intersection B intersection C is equal to 8. I will be concluding this section with this. I will be continuing with the same problem in the next section.